Okay, so let me start with a little introduction before we move on to the questions. First is, India is looking at a very unique position right now. We have roughly 462 gigawatt on the grid, of which we are having, I would say, on theoretical grounds, we have a large capacity of renewable energy, which crosses about 40%, if you look at it that way. We said we crossed 200 gigawatt of late. But the reality is, when you look at the generation of power on the grid, the problem is the grid is actually having almost close to 70% of thermal power, coal-based power, because the actual generation versus installed is two different subjects altogether. And this, in the last 20 years, in spite of all the efforts to promote renewable energy, has remained there. So, a little answer for that. The little answer for that is, we failed in one area, that is the peak storage. We are able to do the base load on the grid, and we have extended the capacities in which solar, which has a plant load factor of only 20%, because you get about 5 to 6 hours of solar power. Only Rajasthan can give you about 8 hours. It acts like a natural battery with an extended 2 hours, but the rest of the states, and maybe Gujarat gets another, it will be 1 hour less, but mostly solar gets only 6 hours into India. And that powers the grid only in that period. So, and the same way with wind, which is an intermittent supply, what happens is its PLF is about, plant load factor is roughly 24 to 25% average now. Earlier it used to be 30% and all, but now we don't get it because of climate change. So even if you look at a hybridized model, the infirmity of these two renewable energy needed a lot of hydropower in. And what happened is, we have not developed enough hydropower in the last decade. Our share in hydro installed capacity is only 47 gigawatt. And yet, if you look at generation-wise, it is the largest renewable energy even now, in spite of the solar and solar crossing 100 gigawatt, wind about 55 gigawatt or so. In spite of that, the generation of electricity from hydropower remains the top renewable energy. So this, I wanted to give you a perspective, so that you need to understand that without hydropower, we are nowhere, because our near neighbor China is 1.5 billion like us in population, but they have 400 gigawatt plus hydropower. They have 300 gigawatt of solar. They have some 270 gigawatt of wind. So you can imagine the scales that we are talking about. We can't continue to say that we're going to run this race, it's a 100 meters race, can't run at 16 seconds. You have to be below 11 seconds to be in the female category and win in that category, or you have to be below 10 seconds if you're in the male category. So we have to run our race in the right time. So this is the time dimension, that reality, before I talk about the further training, skilling and all. So I come to the data. What we want to do is, we want to add, that is REPA's position, my association, Renewable Energy Promotion, says that we need to have 1.2 terawatt, which is 1200 gigawatt of power by 2032, to power an economy of roughly $13 trillion. The potential is 13. We may achieve or not is different, but the potential to jump from the present 4 to 13 is feasible, provided we reach 1.2 terawatt of installed capacity, with 50% of that installed coming from renewable energy. This is the background. Now comes to the question of many researchers and institutions sitting here. We will have to employ something like 200 million people. We have to create additional employments by 2032. And I will tell you the good news, 50% of the employment will only come to two areas, renewable energy and sustainable development goal actions. So I hope the panel knows that this is the most important discussion that has happened in the 2 days. That's completed today. That means we'll provide employment to 20 crore people that can change the destiny of India to develop a 13 trillion economy, powering 1.2 terawatt. So with this little pitch, I would now start the questions. So organizers will have to pardon me, because I would leave things open democratically to people to answer in the way. We have 3 problems today we are addressing, or challenges. One is challenges of skilling, which in our case is advanced skill development, or advanced skilling. It's not basic skill development. The second part we are talking about is safety. We have experts on safety besides us. And the third part is definitely to see whether we can create real traction in training and development for employability. So is the panel with me on this, or you want me to do something different? Okay, so let me first begin with Pratibha Sharma ji. Dr. Pratibha Sharma is Associate Dean, IIT Bombay. She's a neighbor to me because I also come from Mumbai. So my question to you, madam, the first one here is, the first challenge is, how does a apex or ACE institution like the IITs or our NITs, how do we plan? What are we looking at to give our students in the energy dimension? Basically, I would say the entire renewable energy train, and for climate action, maybe other areas also, how the industry can achieve energy efficiency. So these two areas I wish you to address first, ma'am.
Yeah, thank you. And this is actually a relevant question because I am related to academics as well as research. So it is like training the manpower and having the sufficient workforce to achieve the targets which we are planning, and the numbers you have presented very nicely, all those numbers. Other than that, like even now we are talking about the green hydrogen as well. So even the National Green Hydrogen Mission, that also envisions huge development in this area. And it also says like, other than that, you mentioned 20 crore of your jobs will be coming up. Even in National Green Hydrogen Mission, it is like 6 lakh jobs will be coming in green hydrogen area as well. And these will be like both direct employment and indirect employment, wherein direct employment will be related to highly skilled manpower, which will be like designers, developers, you require scientists, engineers, you require policy analysis, you require data analysis, maybe requiring regulations, you have to talk about regulators, and many more. And then there will be indirect, which will be industries, which will be in fact facilitating those developments. It could be construction, automation, and many more. Now, where from this, there are two questions: what we need to do and how we need to do. So what we need to do, definitely being in an institution like IIT Bombay, we need to have structured courses which could make that happen. We have to train the students of institutions, which is not only IITs, NITs, various universities, state universities, private institutions, because the numbers which are required are huge. We have to design those curriculums accordingly. Then it is not only theoretical knowledge that we need people which will be highly expert researchers, scientists, engineers, but the person also needs to be there who has to actually operate that plant, who has to do a regular maintenance. That is also requirement. So, and that all will require a hands-on experience as well. So we need to have those laboratories, pilot projects, wherein these people, they have to do day-to-day work and develop that learning skills and experience of working on those. We need to have very strong industry ties so that they should get that environment of working into industries with all industry best practices, following those safeties standards as well. Then we need to also have on the other side a larger pool of knowledge dissemination, which comes in the form of public awareness and outreach. So we need to have public lectures, workshops, which will also we will also have to educate others to adopt those techniques and get friendly with those technologies as well. At many fronts we will have to work. Also we have to have, there are workforce which is already working in conventional industries. So we need to train them so that they can adopt the cleaner technologies. So it is a sort of reskilling the existing workforce towards this renewable or hydrogen energy technologies, and to make them to adopt that. Now this was like what we need to do, how we have to do. Now if we say IIT will do, then it is a small number. I may teach in a class 150 students, then I'm not able to develop the numbers which you have talked about. So I will give certain examples how we can increase that number. I have been in IITs also, we have several courses which are highly dedicated to all those which we have talked about: renewable energy technologies, electrochemical energy storage, or I teach hydrogen energy for even before we started talking so much about hydrogen, and fuel cells, electrolyzers, all those courses we teach, but we have a limited number of students in the class. I have an NPTEL course, and many of the people I have seen wherever I go, they say that I am your student. This course has been taken up in last 3 years by more than 12,000 students, which are students, industry people, even from outside the country. This is how we will have to have an approach to have larger mass training. Now, second is reskilling. When it comes to reskilling the existing manpower, I am organizing training programs which are for NTPC, oil and gas industries. That way you have to have specific programs which are catered to the industrial needs. And lastly, I will just touch upon some of the other workforce which we are talking about, the plant maintenance people, plant operators. This was when we were not talking about the virtual or these NPTEL courses and all. 10 years back, we organized through MNRE support and in a national Center for Photovoltaic Research and Education, we had 1,000 teachers training program, wherein we had master trainers being trained from IITs, and then we had low cost. So we had 200 centers in various districts in the country, wherein they used to come to their closest districts and attend those training programs. So 10,000 we have trained, and those 10,000 have trained many more. So this is the way we will have to go ahead. So this was like my initial opening remarks, and maybe I will take that later.
First class, Pratibha ji. And I think, we at just a little bit, at the New Delhi Institute of Management, where I'm an out-of-campus dean, we started a program, a small way, for the PGDM students. They are the industry-oriented institution for last 3 years. They got the AICTE CII #1 rank ahead of most of the IIMs. So I can tell you that what is the difference there is, we have designed a program called CRES, Certification in Renewable Energy and Sustainability. I have designed that program with the help of other industry experts. And the teachers, professors are just attending it. And we have now trained 150 students, specifically in that. It's a very small thing, but as you rightly said, these people go to the industry and then they will come back. And we are connected with most of the PSU. We are also connected with NERT and other nodal agencies, something where we can probably collaborate. Next question is to Professor Chitra Rajagopal. She comes from DRDO, an organization that I really admire and respect. And we have one guru, Dr. Satish Kumar, who is now retired, one of the Brahmos man, who is my guru in some ways on the education. He was the NIT Kurukshetra last director. Anyway, madam, my question to you is, how does your background on DRDO and other areas look at a specific objective on the hydrogen economy, its supply chain, and how's the safety parameters, including necessitating circumstance of building quickly standards for, although government is trying to do something. We are also working on something like that. I'm working on a document like that. So maybe we'll consult you as well. What I'm saying is, how do we deliver a robust design, standard and safety mechanism for the hydrogen economy? That's my question.
Thank you. I think you've hit the nail on the head when you said that is essential for a hydrogen economy. If we want to really adopt or go forward on this path that we have all selected, one of the fundamental truths we have to understand is safety and standards are they underpin this. So looking at safety, you have to understand it's a systems problem. You have a large number of contributing factors, interrelations among these. It's a complex scenario. We do not understand many of these interrelationships. So a system safety analysis is very much required. And we do not have, my previous panelist very nicely brought out the entire gamut of skilling gaps and how we need to go about. So I will try to emphasize or bring out the gaps which exist in the safety scenario. So as far as challenges with hydrogen safety are concerned, we do not understand even the fundamental behavior of hydrogen in various scenarios, whether it be gaseous or whether it is liquid. And phenomenological studies, multiphysics models, we need to look into those, we need to develop those. We also need to look at CFD modeling. We need to look at structural models as to how structures will behave when exposed to blasts, or if ever hydrogen goes to a DDT scenario. These are some of the models which are. The other thing is that we do not have a database of incidents, accidents, near misses, and nor reliability, because now we are going to come out with electrolyzers, we are going to come out with new kind of equipment, new components, and we do not have failure or reliability data for any one of those. So unless we have those, we will not be able to do a fault tree analysis or come out with what probabilities of accidents can take place. Also, reliability is a key component of determining the hydrogen price, and also how often the system, how much availability is there of the system, and what kind of maintainability is required. So we need some toolkits in terms of RAMS toolkits. That is reliability, availability, maintainability, and safety. We need toolkits for system safety analysis. We need toolkits for LCA. So these toolkits also have to be developed. So now I've talked of models, I've talked of toolkits. We need database generation. So we need models because hydrogen is still not percolated in a very large way. So we do not have enough data. Even worldwide, there are some pockets where we have, like H2 Tools has come out with the database. HIAD is there, which is a European database. OREDA, of course, we refer to, it's basically oil and gas, but then there's a lot of data which comes from there. But we need to develop our own database. And for that, we need to have some model setups where we can generate this data. In addition to this, we need e-labs where virtually we can calculate the risk. We need digital twins. So there is a plethora of areas where we need to work. And we also do not have on the hardware side detectors, sensors, etc. We need to work on those as well. So the field is wide open. You may be aware that the NGHM has come out with this call for proposals, R&D proposals. And right now it is a mission mode, that is 1 to 3 years, where the proposals need to be at high TRL levels. So that, and with preferably an industry partner, so that you can come out with deliverables in a short time period. Of course, after that, there are Grand Challenge and Blue Sky projects. So to take up all this research, we need researchers, which as the previous panelists had said, we need to train them. We need to train PhD students. Some of the areas which I thought I'll emphasize is emergency responders. We need to train at the plant level. We need to train at various levels. We also need to have risk communication. That is to the regulators, to the policy makers. They need to be sensitized. And then the standards making organizations, we need to have evidence-based, risk-based standards. For that, we need to provide technical inputs. So these are some of the areas I feel we are really challenging, and we need to make a start.
Thank you. In fact, she put up a wonderful point. I want to remind people, maybe you can, those who have not seen or understood it, hydrogen was used long ago. And you must be knowing Zeppelin, the airship. The airship was powered by hydrogen. It used reciprocating engines. Incidentally, I headed MAN. So it was one of the subsidiaries of MAN that built those engines. And just one accident, we had decided that time that before World War II, that hydrogen is not required. So I'm doing a book called The Return of the Zeppelin. And it'll be interesting for all of you because hydrogen is a very old story, even older than electric vehicle, So just we have to be careful when we say data is not available because we did not allow hydrogen to go forward. So that is the reality. And the oldest technology, and when we burn in IC engines, combustion, actually you're burning hydrogen. It's 4 atoms of hydrogen you're burning. And the 1 atom of carbon, if you ask me as a practicalist who's been at MAN heading it and talked to the best researchers on the planet there, they were the inventor of the diesel engine. It's Rudolf Diesel Company. How many of you know, I don't know, but I must tell you that first single piston cylinder engine that Rudolf developed was powered using vegetable oil. So how did hydrogen enter? It only entered later when Zeppelin got the chance, right? But before that was vegetable oil. So all renewable fuel. So how did diesel come in? Diesel name was given to the fuel when it was stuck post-World War II because, this gentleman, Rudolf, was actually shot down by Hitler. And the story goes that he committed suicide. But hard reality is that. But after that, what happened is his colleague, Gustavo Pilstick, started the SEM Pilstick, which was in France. We took it back in 1997. So basic story I'm telling you that this was renewable fuel which was powering IC engines, reciprocating engines. And it included, hydrogen was later, Zeppelin. So it was nothing new. I think the Europe should tell us the true story. I'm luckily with the European guys. I was with them, so I know the truth. And the second is when diesel was, it was made in Middle East, the Americans, our friends, wanted diesel to be powered in these reciprocating engines. So they called it the diesel engine. As simple as that, named after the inventor. And the fuel also called diesel. So this story lies hidden. So it will come out with people like me telling you the story more as we go along. So this is it. So, madam, I can tell you data we have to develop. We can't depend on the West. India should be at the forefront of the hydrogen revolution. So with this question, I now open it further to power sector, power systems, and renewable energy for our next eminent speaker, Professor T. Sundararajan from IIT Palakkad. Sir, my question to you is, being a man who has seen the in and out of the power systems, their ability to respond, especially in current situation where we are putting so much of informed power into the grid. So now our people in the research area, they should probably start learning a subject called harmonics. We are going into transient loading and harmonics. So if this is easy for us to answer, I would like you to put some light on this issue, because all loads are generating harmonics. Caustic soda will generate harmonics. Steel will generate harmonics. There will be 7th to 11th harmonics, different type of harmonics come in. And this is electronic collision. And all common consumers are paying this. No state electricity board is addressing this problem. This is coming in aggregate technical and commercial losses. The last man who addressed this problem with me was Dr. Pramod Deo. But he brought a law also that all the industry should put up active harmonic filters. So this is a loaded question because I saw your profile and I thought I could ask this question to you. So is it somewhere that the research system can come up with this AHF technologies and other things to help renewable energy pump more into the grid? It's not a hydrogen question for me here because it's the hydrogen and renewable summit. So someone has to answer this. Yes, sir. Can I give it to you?
Thank you, sir. Actually, if you look at the energy sector in India and maybe many parts of the world, still the energy demand is being met by coal and petrochemical this thing. But those are producing a lot of pollution, and Indian coal, really, a lot of ash is also there. So it is time that we move towards renewable energy in general. And of course, a lot of progress has been made with respect to solar and wind and so on in India. But the problem of uncertainty or variability, seasonal variability, etc., is something that needs to be taken into account. That is what you meant by giving a lot of harmonics in the power
loads.
Yeah. So matching the load versus the product. But unfortunately, with respect to renewable energy, let's say solar energy gives maximum output during summertime, but then during monsoon time it's the reverse. Solar goes down and wind picks up. But then how to match them? And they have their own harmonics, not exactly, and that with load. So obviously the strategies for storage have to really come up. Even in that respect, I think hydrogen does play a role. In fact, just to add one sentence, in IIT Palakkad actually, we have a center of renewable energy called CORE with 4 verticals. There is solar, wind, biomass, and hydrogen. All right. So what you are saying that matching the the storage versus the production and also match with the demand is something that needs to be done, which means you have to build very strong storage capabilities and store whatever that is possible. Of course, with respect to the electrical side, there are battery technologies are there. I wouldn't say they are very economical yet and also very reliable in certain terms, but then is something that we need. So the way the situation is, whatever is available, use it to the best extent possible and optimize between them. So optimize between the renewable options, optimize between the storage options and so on. And hydrogen storage has safety problems, has asset storage problems as well, because hydrogen is a very, very light gas. So you'll end up storing small mass of hydrogen in very heavy tanks. So how to really bring down the weight of the tank, etc. How to develop materials, maybe composite materials which will be light weight, having light weight, but then can carry good amount of the hydrogen fuel. So these are, I would say that we can't look at any problem as a single problem, but it requires a more comprehensive kind of understanding, both renewable energy as well as the fossil fuel-based energy, and not only problems of developing the, let us say, energy resource, but also storing it, transporting it, all aspects have to be looked at in a holistic fashion. We need to do research and also maybe even, let us say, industrial development to bring out a holistic type of a balance between what is available and what is required, and essentially remove the harmonics which are there, unwanted harmonics in the power management. So that is my take on this.
Now, I brought this topic because very rarely people discuss the harmonic part. No summit, nowhere they are discussing this issue, and it's a major problem. 20% of our current losses, even now, whatever little AT&C we are talking, still country loses 40% of the electricity produced. And in that 20% level, I would tell you, will go towards the harmonics mechanism. So we do not have AHFs manufactured in India, and this is an area of research for all of you. So that's why I threw this question to this panel, because one of my friends who died actually had a company in Pune called, this is DB Power Electronics. They were the only Indian company that made AHFs. It later on was taken over by Chloride France, and Chloride in turn was taken over by Emerson. And I don't know what happened. Suddenly this whole AHF business is gone. Nobody's speaking about it. So this is the background. His name was Pradeep Pimple. Late Pimple and me were great friends. He developed his own active harmonic filter in India. So I have not seen a second company. The companies that make it is ABB and Schneider now. I don't know anybody else making AHFs. So it's an area, or all the institutions that are here, anybody who's interested to work and push the governments to adopt. Because this has to be put on the load centers. That is, the factories have to put incentivization. ENERT could probably create, Belluri Saab is here, they could create standards for this. Huge power can be saved, and this power can go to common people. Now my next question, because I saw that similar kind of question has to be given to Patel Saab. That's what they have written. But I would a little bit go back to what I said. And that is, when I said in the beginning that we are looking at a 2.2 terawatt of electricity coming into the grid, not a generation, but at least installed. So we can say safely that 50% of that would be generated, right? So in such a scenario with whole type of hybrid energy, we call it HIRED, Hybrid Integrated Renewable Energy Development. And if you want to call it national, you can call it NIRED, National Hybrid Integrated Renewable Energy Development. For states, it's HIRED. For country, it is NIRED. So how do you think this can be really balanced? And how does the hydrogen economy itself retrofit into this renewable hybrid?
So thank you. So as you said, right, so renewable energy is one of the main source that will be implementing in the future grids of energy. And if we think about green hydrogen itself, so if we consider the technology, which is what we are looking right now, it's using renewable by using electrolyzer, the water electrolyzer. So if you consider even that technology, and the major goal in that is to bring down the cost around $1, which is about, let's say, 80 to 100 rupees. And if we look in that scenario, to produce 1 kg of hydrogen, you require 40 units of electricity. And that itself, if you even be very modest, let's say if we consider even 2 to 3 rupees per unit, we are just costing about $1, that itself. We are not even considering the cost of electrolyzers there. We are not even considering the membrane, the electrodes, all those things has not even added up. The other rare commodity I will add is that, for produce 1 kg of hydrogen, we require like about 9 kg of water, fresh water. And that soon will be very scarce, because we know that, we'll be facing a huge problem. I'm coming from Bangalore, and we're already facing, because we have no rain there. So how we going to get that? So that's another major issue. So in that scenario, I feel that, we should look beyond that. One is that, we should introduce something which can replace fresh water. So for currently, what we can do is we can integrate the wastewater into our system, so that at least that cost can be reduced. For example, if you use water splitting, you use oxygen evolution reaction, which is very highly energy intensive. So if you replace that, for example, what we do in our lab is we use urine. Let's say urine coming out from, and it has urea in it, which the thermodynamic voltage that required is about 0.37 volt. So which is about 75% less energy required than of water. So although it doesn't come down to that, but at least we can reduce at least 50% of the energy that is been required to that. So that can really lead towards the goal which we are looking towards is about $1 per hydrogen production. Talking about the other thing is that how to integrate with the solar and the wind power, because that's very dynamic. And with that dynamicity that is added to the electrolyzer setup, there is a huge problem connected to the electrode materials. Now to solve that, we have to look towards it that how the nanoscience and nanotechnology can be implemented in that area. Because see, we know that we cannot use platinum or we cannot use any noble metal for that case for the electrode material. So we have to see that, we have to replace that. To do that, we have to see to it that we use non-noble metals, but that too at nanoscale, because the property of those materials changes at that level. And that can really increase the performance of that. So recently there was this research that shows that, if you use certain material, make a compound of it at nanoscale, it can become a self-repairable materials. So like, for example, if you want to use wastewater, or even there are people are looking towards seawater as a source of electrolyte. So seawater has a highly corrosive environment. In that scenario, how we can able to produce those materials which can sustain that. So for that case, we require self-repairable materials. So if you introduce something, let's say a small electrolyte in that, which can repair the surface and can operate again in that case. So in that scenario, we have to see that how nanoscience can be implemented in this kind of material development for the electrolyzers. Not only that, we are looking towards photoelectrochemical cells, where we want to use direct sunlight and produce hydrogen. So there we are talking about solar to hydrogen conversion. So that efficiency, people have been working for years, but that is not going above 5%. So that has to brought up, and where again this new technology or cutting edge research can really be useful for that case. In area of hydrogen storage also, so Pratibha madam is already working in that area. She might be doing it very well, that how when we go to the nanoscale level of the material, we can store more and more hydrogen in that. Especially if we want to increase the kinetics of those hydrogen adsorption and desorption, those also can be improved for those kind of materials. So there's a huge scope in improvement, but I think it's very important that we have to implement through the material research. This can really be useful for implementing our new technology into the system.
So wonderful. Actually, you gave a very good insight on the material part. I had an experience in 2009 of being called by the Canadian government. I visited 3 universities in Canada. One was the Waterloo, the second was the British Columbia, and the third in between was the Alberta. It was at Alberta that I met Indira Samarasekara. She was the president, and she became my fan when I was talking to her on these technologies. So they introduced me to a very interesting technology called phenylsilane. It was developed at the university, and I will tell you its efficiency, they demonstrated to me, was 29% field efficiency. And I'm very surprised that that did not come out, and the reasons that I have for that, 2009 to 2025 is, there are forces, we know what forces are. Like First Solar wants to promote cadmium telluride, and the other one, gallium arsenide, arsenic comes in. They are not thinking of these materials becoming a problem later on. So unless this kind of, there's some lobbies on all these things. So if we don't work against this kind of lobby business, they will move from silicon to this. It is of no use to us. So phenylsilane was silicon with tinning. So what tinning did to silicon is, it made it hyperconductive. And now the only challenge was how to control the constant voltage supply out of it. So this is a small feed I'm giving you. So this type of game changer is available to Indian universities. They must go, because they were looking up to some IIT or NITs going there and making an MOU and then going pilot project with the government. So this is a feedback I'm giving you. I can help in coordinating. That's what my Renewable Energy Association does. So I wanted to mention when you said this. The second point, very important, is the Pinnapuram scheme, where, Veluri's friend, Dr. Ramana Reddy, I was mentoring him in NRED CAP. Low-hanging fruit was to be caught. So what we did is, we said, the price of solar has come down. So we power in the Pinnapuram, the case study is there with us in one of my white papers. So there we said, power the pump storage using solar. So that resulted in a major game. That's a great case study. It's a hybrid project. It has 4 gigawatt of solar, of which 1 gigawatt they have installed. 1.68 gigawatt of pump storage using Andritz 240 megawatt machines, which are reversible pump turbine generators. And there is no PPA for this project. The project is working on discovered cost. Average discovered cost of the grid is 4 rupees. Average peak storage cost is 6 rupees 30 to 7. So it's a Swiss challenge method on which it will operate. Very large project, 2,200 acres of land. I visited it. So it's not that I'm theoretically talking. I know what's happened there. So after mentoring, we have seen the success on the ground. So I would say university level people should train people in this pump storage now. That is my request to panel, start this discussion on the subjects everywhere. So that we need a lot of people in pump storage. So my next question goes to Dr. Radhakrishnan, Unni, and he comes with a different background, so a little bit of finance there. So I think I will twist and direct the question towards that. How do we fund research in renewable energy and related areas, including hydrogen, when our whole spending of the largest spender is BHEL, whose spend is only 2.5% of the total turnover? About 2.5% of the total turnover is what BHEL spends. I would say a company like GE would spend about 5% on R&D. The companies like, these defense companies in America, they spend close to 8 to 11% on research and development. So I'm giving you ballpark figures of different. So how do we sort of tackle this? Because money available in research is absolutely drying out.
Good afternoon, all of you. I'm privileged to be surrounded by a panel of academicians. If you look at both the extremes, we both are financial professionals. So Professor Iyer sir is a financial professional. I am also into finance. So that shows the importance of finance when it comes to any technological advancement. So we both are the both extremes. So that's just a coincidence, I would like to say. So thank you again, Iyer sir, for setting the context for the talk, because we have been talking a lot about education. And when you talk about education, I feel there is a word change, which is inseparable with education. When you talk about education, change is inevitable. I'm very happy to talk about the robust education system that we have developed. But nothing is perfect in the world. Over a period of time, it needs to undergo a lot of changes. Unfortunately, in our country, the system that is changing is very slow. So I feel we need to learn the way we change. We have to change in a more faster way than it is supposedly to be done. Most importantly, I can tell you, I have studied the textbook that my father learned, and my daughter is also studying the same textbook, and I'm sure my daughters or next generation also will be studying the same textbook that we have learned. Why is this happening only in education sector? When you take a mobile phone, this was not there 15 years ago. That underwent a lot of change. Computer was not invented at that time. So each and every sector you take, there is lot of changes happening except in education. So I'm talking about 1.4 billion population in India, of which 600 million are belonging to youth. So we are a young country, but the most important thing, the education is not changing. That is the main reason why Jain University took up change as the most important factor in education. Be the change, be the future is the catalog, is the punchline for Jain University, because future is change. We should be futuristic only by adopting changes. Over a period of time, if you look, the role of teachers are also changing. Earlier, when I was a student, if I had any doubt on any particular subject, I used to ask my professor, "Sir, what is the answer for this question?" Now things are changing. Everything is at the fingertip of a student. There is no requirement for a specific teacher. The student has the right information. As a teacher, he should be a facilitator. A teacher's role has changed from a teaching as perspective to a facilitator role. So this kind of changes should happen in education as well. So coming to your question, Dr. Pratibha, she already mentioned it very clearly. R&Ds are the key. When you come to a new invention, new technology, which is a completely new thing, which we don't have more information on it. So R&D support should be given by the private companies, the top 1,000 companies. They have lot of funds for R&Ds. These R&Ds should be utilized for the development, because we are talking about something. Why it is very important? Because tomorrow or the day after, we are at the verge of losing what we have now. This petrol or diesel or whatever hydrocarbon we have, it's going to end all of a sudden. So it is high time that we think about a renewable energy option. So I would put this question to Pratibha ma'am again, to find some kind of options wherein we can do the funding through the government channels, and as an educator, our role will be to design curriculums, courses, and all required materials. And being a private university, because of the autonomy structure that we have, we can design courses according to the requirement. And very happy to announce that even for undergraduate courses, we don't require a UGC permission as of now. So in case if there's a new project coming up, or a new technology coming in, we can design courses being a private university. The other day, I was talking to one of the members from a reputed university in Kerala. I asked him, how often do you change your syllabus? He said, we have an academic council meeting and we do the changes once in 2 years. I said, when did you change your mobile last time? He said, I changed my mobile 6 months ago. I said, sir, you are changing your mobile 6 months ago, but you're talking about education, which is the high priority, which is changing only once in 2 years. This is not possible. You should think of changing this syllabus curriculum minimum once in 3 months, or once in 6 months, or down the line once in a year, which is not happening, unfortunately. So that's my point on this particular subject. Thank you.
In fact, it was wonderful to hear from you. I have a point. We at CREST, we have done something unique. We keep changing our own courses, and it is less than 3 months, I can assure you that. So we keep adding, changing. And there is right now one researcher, a lady who's about 50, she wanted to come from AI into renewable energy. She's an Android. I can't disclose the name right now. She is doing an immersion PhD. Topic is use of AI and IoT in renewable energy. And topic I have introduced. It is not a university topic. And I am like an unofficial guide to her, but official guide, because we at REPA are guiding such people. So this is interesting. So if you, public-private participation body like us can enable any university, whether it's a private or public, to go forward. Because that is way, and government mostly is ready to accept this, because if it comes from a third party, even, we can work with ENERT also. What is Kerala's needs? For example, I was watching somewhere that it was being thought that through this process, they need to find out that Kerala becomes a place for training and development of people in both the hydrogen economy and probably this hybrid renewable. So this could be a mission. Valoris, are you listening up? This could be a mission between REPA, you and all these fellows who are sitting here. So very wonderful to have this. Now since we have very less time, because that should have been 2 sessions minimum, like 2 rounds minimum. But I would now do something. Each one of you is a specialist and you know your subject very well. So if you can quickly put up 1 or 2 points each, which you want to see in the training, development and education sector, that should change. That should come from Pratibha ji, and then Mike can continue.
So actually there are various countries, if you see, when they have, let me speak in terms of hydrogen, because that being very close to my heart, when they have launched their mission documents or target strategies, they had a clear-cut skill development roadmap as well. We can take examples and we can have our own set of dedicated maybe frameworks as well. There could be cases like where we can have a comprehensive nationwide frameworks, and there could be localized also. Depending upon maybe some regions, there would be a certain set of industries which will be adopting hydrogen. Those could be dedicated skilled or training programs could be dedicated for that particular region. Some could be for overall region, and definitely the PPP model will work well, wherein government has to come up for those should be industry driven, industry related problems, and research institutions, CSIR labs, they can be a partner wherein they can provide that education and skill development. And definitely that bears a cost. So incentivizing that also will help, because companies will not pay for that and individuals may also not pay. So that incentivizing individuals as well as companies for undergoing those trainings will also help. That is what I feel.
I think I'll like to emphasize the importance of harmonizing standards, safety standards. That is, I think, very close to my heart, because if we want to be a net exporter, finally, we need to be sure that what we are producing and all the standards which we are meeting should be at par with the global standards. Also, adoption of best practices. So for this to happen, we need to have a lot of collaboration with other countries. And of course, we are already doing that. In fact, I'm also part of some of the Indo-German and Indo-US and various other collaborations. And I think the country at large is also collaborating with others. This will help us to leapfrog. Not only that, of course, the best practices, as I said. Secondly, the standards which have been evolved, I mentioned it in my opening statement also. We cannot go for, worst case scenario based safety distances and standards. We need to look at the probability of the occurrence. We need to look at, for example, if you have to site a refueling station, you may not be able to follow as per some laid down norms, which is a one-time occurrence, is based on a one-time occurrence, you have a certain safety distance. You may not be able to meet it in practical terms. So you need to have risk-based safety distances. You need to have performance-based design criteria. So these are some of the things I thought are very, very important. Collaboration with other countries, leapfrogging, so it will help us to leapfrog, harmonize the standards, use risk-based, evidence-based standards. In terms of skill development, I would like to say, from my experience in the defense, we had a state-of-the-art skill development center where we had field exercises for all our armed forces personnel on fires, explosions, and releases. We also, of course, had theory courses, but many of these courses are mandatory for their further promotion. And we had model fire stations and model equipment where they could train themselves. I think that is very important for the hydrogen and for renewable energy also, where we can have actual fields hands-on training. So I think that is all from my side.
Yeah, I think that especially with reference to this renewable energy and let us say even hydrogen economy, etc. In academic institutions, a lot of research work is going on, but then it almost stops with that. The next thing from research would be to commercialize and take the technology to the level of larger scale implementation. But then the next step will be to develop the manpower required for really commercializing the technology, etc. And here and there we see that there are special courses offered on, let's say, some of the new technologies. But then it not only stops with the knowledge, but also should go to the level of skill. I think both are important. I think one has to have special attention to this skill development. At IIT Palakkad, because we have a lot of tribal communities nearby in the mountains, we do take up this kind of skill development. From time to time, we do that. But in certain areas, identify that and then offer a skill development program itself on that. That is necessary.
Yeah, I would like to add that, to make the renewable energy and the hydrogen as such a success in our country, we should learn from one success story from our country is cricket. If we look at it, how the cricket has grown, there was one single model. Catch them young, groom them, and watch them grow and perform. So why we are not talking about, implementing or at least educating this renewable energy, the importance of hydrogen energy to the school kids, to the college students? Why can't we developing, let's say, if you are not able to take them to the real site, can we have a digital twins, virtual reality, where they can be trained, they can be at least seen that, whatever seeds that we are putting it right now for 2070, those are the people who will be actually, getting the fruit out of it, not us. So we should at least make them see that, okay, this is the future. And if we instigate that motivation in them, I think that will be a really useful thing in coming future, because those are the people who will be innovating, those are the people who will be implementing those technology. So if we train them now, we'll be having a better future. So that's what I think it should go at very young level training rather than going at much higher level. Thank you.
Yes, last but not least, we have Radhakrishnan sir.
I would conclude my talk focusing again on change, because today we are talking about hydrogen energy. Tomorrow we might be talking about getting electricity or generating electricity from thunder or lightning. We don't know. So these are new areas which requires a lot of attention, which we have never explored. So we don't know whether the diets will change from hydrogen to other renewable energy sources. So again, coming to the change, this has to change. The change we think, the change we adopt should change in a faster pace. So universities should adopt or should foresee the changes that can happen in the future and should align their curriculum projecting to the future, not to the relevant. The courses that are running now, talking about artificial intelligence or machine learning, they are the talk of the town. We don't know what will happen with this particular course after they come out of their university. So a good university should focus on an education pattern that should cater to the future generation, future qualification. This is what I meant. Thank you once again.
See, there is a French saying. I'm happy that all of you have brought forward the best we could do in this time. But there's an old French saying. It says, when everything changes, actually nothing changes. So it has happened in my sector. We used to talk about power systems and industrial automation. So we saw, when I was heading MAN, we brought a computer-controlled surveillance system for our marine power plants, which were running the ships. So that we installed on stationary power plants in India. I did 4,000 megawatt, my friends, in the country. In captive sector, it's a record. Our Chinese friends only did 3,000 megawatt. We beat them black and blue. And this was the 90s, So we have defeated them once. And my friends, what's the life? I add that capacity. We did 6,500 megawatt that time. So we used the computer-controlled engine surveillance systems, and they were the automation system. So if you put the IoT on top of it today, and AI, we are only doing the same thing, remote management. And I saw this remote management at Jindal first time. That was the Jindal Steel, the elder brother, Naveen Jindal. He had a small room in, Delhi building of August Kranti Maidan. And from there, he could see his Raigad powerhouse. Even a nut and bolt is removed, they could manage and see it. Now this has become the I would say the war house or war room type of thing in almost all the enterprises, where the chiefs are getting hands-on information from the system. So I believe, all this, somehow I'm a little bit of a critic, all this brouhaha about it's come yesterday, today, and things will change. I can assure you that in the renewable energy, like in power sector, in the past, any boy or girl coming out can safely continue for 30 years with what they know. So please don't think of it like the IT sector. IT should not be front-loaded on the hard economy, which is a brick and mortar, and the black economy, whatever you talk. It's no more black, it's getting green, my friends. So this is my message to all of you. So the French saying is right, and I leave you with one thought, that the journey from the mother's womb to the tomb, there is only one fill in the blank. And that fill in the blank, you can only put two words, my friends. Either you write eventful, you're all happy, or you simply write eventless and then get lost. So I hope we are the first one, all of us in this room. Thank you, and thanks to all the panel. I hope the organizers can take over now. We have finished our discussions. Thank you. Thank you all for being here.